Hello everyone, this is Module 2, Part 1 of Introduction to Structured Query Language, Chapter 2. Our chapter objectives is to understand how to use extracted data sets in business intelligence systems, along with how to use ad hoc queries with BI systems. We're going to cover the history and significance of structured query language, so where it came from and kind of where we are now, and some of the added features or new features of SQL that has been added over the years. The meat and potatoes of this chapter we'll spend the majority of our time is understanding how to manipulate and work within the select from where framework, which is the basis for our database queries. This first part 1, is considered basic SQL, where we'll be retrieving data from a single table. Within our select from where framework, we'll cover the use of some of the clauses that go along within our where. After our where clause is order by, group by, and having clauses. We will also cover keywords for our SQL queries, like distinct and percent, as well as operators like between, like, and, or, and not operators. Okay. As we move on, also we'll be covering some of the built-in functions as well, like sum, count, min, and max. But as we move on to what's considered advanced SQL, we'll be retrieving data from multiple tables. Okay, so when we get into retrieving data from multiple tables, we'll get into the concept of using joins or join on operations and inner and outer joins. We will also cover subqueries as well, which is another way we can retrieve data from multiple tables, as well as from single tables and restricting data based on information that we retrieve from another table. And lastly, we'll cover the operators union, intersect, and except. Okay, so part 1 and part 2 of this recorded lecture will cover the first 10 chapter objectives that we just covered, mostly involving single table queries or basic SQL. Okay, so the book first starts out, chapter 2 first starts talking about ad hoc queries. So ad hoc queries are what we use to answer questions using the database data that we've already collected. Okay, so for example, the example they give you here is how many customers in Portland, Oregon bought our green baseball cap. So obviously we would need to create some type of query to query our database to retrieve this information. So if we had to make some basic assumptions, we may have to query a sales table within our database that's recorded, and we can put in characteristics of, baseball cap, and maybe specifically with the attribute of green, and it can bring back some information that would help us answer that question. Okay, so that's kind of what an ad hoc query is. It's created by the end user as needed instead of something that may be built into an application. Okay, these type of scenarios or these type of ad hoc queries are common in business. So not all users necessarily know the SQL, but they have the ability to create these ad hoc queries to retrieve information from our databases. Okay. So as we stated, ad hoc queries are dynamic, so they can't be created prior to the moment that you need it. So, and again, as we stated, most users are non-technical people, so they have the use of ad hoc query type tools, and I think the tools that the book goes over or uses is tools that are provided to us from like Microsoft Access or GUI friendly type tools. Because they're non-technical, or most people that use or query databases don't necessarily understand or know SQL, these query tools allow them to use these different graphical user interfaces to navigate through the database using specific object structures or drag and drop type features where they can form these ad hoc queries to retrieve this data. Okay. I guess the key feature, or what we need to understand here from Chapter 2, what they're trying to say is that a lot of users use these querying tools to access these business intelligence systems. These business intelligence systems are, and today, what drives business in assessment, analysis, planning, and control. All of these areas are strategic objectives of any organizational unit. This empowers organizations to not only create knowledge about their customers. So if we in thinking about that, thinking about how you can strategically sell what you've sold, what your profit margins may be on sales on a particular item. This may give you help you be able to provide knowledge on some of your competitors and how you stack up against some of your competitors based off of information that you've collected. How you interact, or your business partners that you use, your systems, and you may share a common system with your business partners, and you can analyze and assess how those systems are working. But the moral of the story is that business intelligence systems are used in all internal operations of an organization to make strategic business decisions on which way they should go and how they should be going about doing their different business processes. Typically, business intelligence systems are going to be broken down into two information processes that create this knowledge. I think the book talks about OLTP. OLTP, I do believe, is covered on page 37. OLTP and OLAP. But OLTP is online transaction processing. This is the process of gathering the input information, processing that information, updating existing information to reflect the new information that's been processed. Most operational or internal databases support OLTP, or most database management systems. So if you have a database that you're using as an operational database, or something that changes quite often, that handles your daily operations, that's where we start talking about OLTP. Okay, things that's happening in real time by multiple users, keeping your information up to date, keeping your information, the integrity and availability to multiple users at one time. Now, when we get into OLAP, or online analytical processing, this has to do with more like data warehousing, data mining, where we use this information to support that decision making or those business intelligence systems that we just talked about. So some database management systems can support OLAP, and in the forms that they supported, depending, like in the example of Microsoft SQL Server, which we'll be using for this class, Developer Edition. The Developer Edition has many features in regards to analytical features and reporting features that help some of these analytical processing type functions within the database. But in most cases, only data warehouses store OLAP or support OLAP and not OLTP. Okay, but again, data warehouses is where users would use those business intelligence tools to interface with the data warehousing to help with those analytical type processes that they're maybe using. So just to take a look at the components of a data warehouse. In most cases, business intelligence systems store their associated data in data warehouses. And data warehouses are database systems that have data, programs, and personal specialized type prepared data for business intelligence processing. As you can see in our components, we can collect our data from a number of different sources. So it can come from operational databases, any other internal data, and that could be, spreadsheets that may be collected, or maybe another different type of database, maybe an internal access database or whatever else, or some type of application, as well as any external data. So we can collect data from a number of different sources. The key here is, in the data warehousing system, is your ETL system, or your extract, transform, and load system. This is the system that prepares the data for business intelligence processing by the database management system. Okay, so when we talk about the ETL system, this ETL system gathers this data from a number of different sources, formats it, structures it. That's when we talk about cleaning. Okay, so it has to have the ability to interface with these sources, read it, understand it, change the structure of what it's receiving, and then form it or put it into or prepare it into the forms and structure that we want in our data warehouse, so our database management system can manage it. Okay, so all of the rules and stuff that we put in place, or consistency checks or validation rules, are implemented in our ETL system. So that's why it's so important. And then from there, again, our database management system will store our data itself, and then the metadata about the data, or the information about the data that we've collected, so our end users that use these querying tools or business intelligence tools can access and implement or access these libraries and data to do what they need to do. Okay, let's take a look at a kind of a breakdown of the ETL system. This is just kind of giving you some information on what it's doing. Again, the need for advanced data extraction and filtering tools. Again, that leads to being able to understand what it's interfacing with, being able to read data from multiple data sources, being able to take that data, transform it, filter it, and then being able to store that information into a data warehouse. Your ETL system is typically done, or the information gathering or pulling this information from different sources is usually done on batch or schedule type extraction schedules. So it's not something done on a daily maintenance type basis. It's more done on a annual or schedule type basis, and it supports, again, multiple data sources. The key thing is it's going to check for any inconsistent data or any validation rules that you've already put in place, and then again format it, prepare it, and then store it how you want it to be. Now let's change gears here for a second, and let's talk about the Cape Cod Outdoor Sports. Cape Cod Outdoor Sports is what Chapter 2 uses as kind of a real-world example of how we would start taking existing data and then transforming that information or extracting that into a new database for a business intelligence system. So in this particular case, we have this Cape Cod Outdoor Sports system, and this is kind of just a screenshot of what their website would look like. But a breakdown of Cape Cod Outdoor Sports: there's 15 retail stores, an online internet store, and then a mail order department that handles all of the sales. And their operational database is kept and stored in a Oracle database management system. Okay, so what in Chapter 2 we're doing in regards to the extraction, remember, the extracted information from a database and used into a business intelligence system, what they're doing is they're going to, and here this shows all of the different sources that they will get their sales information or their sales structure and how it's stored. And then what we're going to be doing is extracting that data from an Oracle database into a offline separate sales extraction database so they can analyze specific sales. Specifically, this is the marketing department that needs an analysis of in-store sales and catalog content. Okay. Again, they're going to be extracting this into a separate offline database that they'll use to do some analysis and assessment and strategic planning. The 5 tables that are going to be used in this extracted database is retail order, order items, SKU data, and then catalogs from 2014 and 2015. The extracted data will be converted from, again, a Oracle database into a Microsoft SQL Server database. And then the last converted version process would be, we would convert from the operational database. There's a column called order date, which will now become 2 columns of order month and order year. And here's an example of those 5 tables that we're talking about and the columns. Notice in retail order here in our extracted database information that order year now becomes month and year. We have it broken down with our associated data types. Okay, so here's just an example of what the metadata will look like in our extracted database for this particular real world example. Okay, this next slide is a kind of a breakdown of the extracted data tables and how the relationships or how the tables are associated with one another. We have our one-to-many relationships between retail order and order item and SKU data and order item. This indicates that one retail order may be linked to many order items by order number, and then same thing with SKU data. And then the catalog tables are not linked to any other tables. They are just really storing information, all the information of the SKU or products that they have sold. So you notice there is no relationships to any other tables there. Okay. In terms of the common columns, this should be familiar to you now, especially if you've completed assignment 1. If you completed assignment 1 part 2, this is where we created these tables within the Cape Cod database. So again, retail order, order item, and SKU data all have relationships with each order, with order item being the having a composite key of order number and SKU to link it back to the SKU data and retail order tables. Okay. And then here's just a breakdown of the, again, catalog tables with its primary keys, again, with the information that is collected. So let's skip another step here and let's start getting into SQL. So what is SQL? By definition in the book, SQL language was developed by IBM Corporation in the late 1970s, was endorsed as a U.S. national standard by the ANSI Institute in 1992. So it became a standard in 1992. Since 1992, there's been several different versions of this ANSI standard. I think with the latest being the SQL 2011, which incorporated XML and some object-oriented programming concepts. These concepts and these features are discussed later on in this book, but again, we will only cover from chapters 1 through 7 in this class, and I do believe these features are covered in more so chapters 9 and 10, I do believe. Okay, so it's there for you to check out, but we won't spend a good deal of time talking about the new features. Okay, SQL is a programming language, but it's not a full-featured programming language like C, C# or Java. What that simply means is that SQL is a sub-language for creating and processing database data and metadata. Okay, so when we mean by not full-featured is if you understand programming in C# and Java, we know we can do quite a bit with those programming language, where SQL is kind of limited to creating and processing database data only. Okay, now SQL is very important. It's a critical skill. If you understand SQL syntax and programming, then you should be able to utilize this within any enterprise class database management system. SQL is ubiquitous in those. So again, this is a very important skill. There will be very few times, especially in today's time, where if you're developing some type of application or application program or something like that, where you will not interface with the database. So SQL is definitely a critical skill. Some of these statements, or the SQL statements, pretty much can be divided into 5 different categories. For Chapter 2, and what we'll be doing in our Assignment 2, Assignment 3, and Assignment 4, for that matter, will be considered data manipulation language, or data manipulation language type statements. Again, those handle querying information, handling insert, updates, deletes, or retrieving information and moving things around. There's also data definition language. We'll spend more time talking on data definition language in Chapter 7 or later on in this class. But you also too have SQL persistent store modules statements, transaction control language, and data control language statements. So these are the 5 categories that the SQL statements will be going over, will be covered in this particular class. And as we said, the data definition language will be statements that you'll see, because if you take a look at some of these scripts that will give you, like the Cape Cod script, and then the create tables and insert data, as well as the Queen Anne cleaning service script, you'll see that is considered data definition language, where it's used to create the structure of your tables, define your relationships, and any other data definition type statements that are issued to create your database and tables. Okay, so data manipulation language statements. Again, these are our this is the select from where framework that we'll be working in, but this will be used for querying, inserting data, modifying data, and deleting data. And that's covered in this particular chapter, Chapter 2, what we'll be doing here. Okay, so querying is in our select statements. Inserting statement, we'll be using the insert keyword, as well as update and delete as keywords for the corresponding processes or statements. SQL persistent store module statements, we will touch on it generally, briefly in Chapter 7, or general introduction, but if you want to get more information on that or spend a little bit more time on that, again, that would be Chapter 10. But procedural programming type statement capabilities help us with if we wanted to add variables or use control flow statements, where again, that would be where we would move maybe the cursor around and read different lines of code within our SQL statements. Transaction control language, we won't cover this in this class, but at least you need to know what it is. This is used to mark transaction boundaries and control transaction behavior. Chapters 9 and 10 also. Data control language statements. This is more of the security part of where you use, and we will touch on security in our last module, but this is used to grant database permissions to and from users and groups. Again, covered in 9 and 10, but in our last module, Module 8, we will have some additional resources that we will use to cover some of our data control language and some of our security concepts in this class. So the last slide here of part 1, I wanted to make sure that we understand that some of you may have heard of CRUD, the CRUD process, but the actions that in our data manipulation statements refer to a lot of the CRUD process, which is create, read, and update, but the equivalents here are illustrated. So the creation process is equivalent to our insert statements. The read processes are equivalent to our select statements, and update and delete are corresponding. The term CRUD is not used in this book, but you should know what it means. So anytime you see something that has to do with CRUD matrix or breakdown like that, you understand what is the SQL equivalent to that particular CRUD process. Okay, so this is the end of part 1.